This conference will now be recorded.
Okay, so one quick request, guys, is that I've been hearing a lot of feedback from people, so I'm just trying to let's say elaborate this out. One quick request from my end is that questions that are related to let's say on a real-time basis and etc. We'll try to take them after 8:50 in the last 10 minutes. If it's not sufficient, you all can please go ahead send me an email across, and I'll try to spend some time, let's say offline, to take the questions out here. Questions that are related to let's say the subject that we are discussing about in the current class, we can take them let's say in between and cover them out here as such. This is to make sure that people who do not really follow the question are not lost with the session. So that's the only intention out here. With that, we can get started. So yes, any questions that I can take from yesterday's session, any questions that I can really any quick questions I can really answer from yesterday's session out here as such. Anyone, any quick questions that I can take? All right, so let's get started. So this is what we were discussing yesterday, is that in order to secure resources and in order to create your own space on a public cloud like Azure, you will need to make use of something called as a virtual network. So what did we do yesterday is that we went ahead, we created something called as a virtual network, and then we secured a resource called as a storage account out here as such. Now, when we create a virtual network, I'm telling that what, you will get your own private space. So Azure is going to establish your own private space out here, and they'll give you this particular space out here, telling that okay, fine, what, you have your own space. Just go ahead and manage. You can just go ahead and manage your own space, do whatever you want with it, secure resources, and so on and so forth. Now, when I say space, right, just think about like this. People especially who are not from, let's say, pure networking background, just think about it in this way: that you are going ahead and you are looking to buy a land in this particular city, whichever city that you live in. You want to buy your own private space out here. So you go ahead, contact a real estate agent, telling that what, I want some amount of land. Now, what would be the first question he would ask you? Just think about it in, let's say, a very layman terminology. You're trying to go ahead and buy a land out there, okay? So what do you think is the first question a real estate agent would really ask you out here?
How
Anyone?
much space you are looking at?
How much space you're looking? Yes. How big or how small of, let's say, a land that you want. In the same way, when I create something called as a virtual network in Azure is going to ask me the same question, but it's not going to ask me, okay, fine, what is the space you want? But rather, it's going to ask me, what is the address space? What is the address space you want? And if we define something called as an address space, this will tell you how big or how small is your network. This is what address space is now going to decide. For example, if I go here and say virtual networks today, now it's telling there are no networks that I hear that I can really display out here as such. So I'll just go ahead, create a new network for myself. I'll say, okay, fine, create a network. And inside this, I'll just go ahead, create a new resource group. I don't have one today. So I'll say it is network RG. I'll say, okay. And I'll say the network name is something like sample network. And I'll say the network is in a region called East US2. And then I have something called security. And I'm not really touching the security at this point. I'll say next, IP addresses. And this is where it's telling me that please give me something called as an address space out here. I'll just go ahead say, okay, fine, let's go ahead delete this out, and let's go ahead delete this complete thing out here, delete the address space. Yes. So it's going to look something like this. So when I say add IP addresses out here, it's now telling me, okay, fine, Do you want to add something like an IPv4 or something called as an IPv6? I'll start with something called IPv4. We'll talk about what IPv4 and IPv6 are. And now I'll say the starting address. I'll say it is 10.0.0.0, and then it's asking me what is the address space size. And in here, if I just click on this, it's now telling me /2345678 so on and so forth. And finally, it's telling 232 and all those things out here as such. What I'll do is I'll just go ahead, say /16. Just see this. What I did is that firstly I gave a number telling it is 10.0.0.0. I just give a number out here. Then I put a /16 to this number, and as and when I did it, Azure is now telling me that, you know what, in this space, right, you are going to get around 65,536 addresses. The space will just decide how big or how small your network is, and it would also go ahead and give you the IP addresses. It's going to give you something called as an IP addresses out here. But how is this even getting calculated? Like, what is the logic of, let's say, calculating this out here as such? In order to, let's say, go into that fundamental basic, let's go there. I'll just make use of a notepad in order to, let's say, explain this out. So when I'm giving something called 10.0.0.0, let's put the /16 apart from, just put the /16 aside right now. When I'm telling it is 10.0.0.0 out here, for you and for me, this is an actual address. We are able to, let's say, look at this and we're able to tell that this is 10, this is 0, this is 0, and this is 0. But for Azure, at the end is nothing but a server somewhere that is hosted or somewhere just running out there. Server again is nothing but a computer, very simple. But for Azure, right, this address will be converted into a different format. For a computer, for a server, this address needs to be translated into a binary language, zeros and ones, which means that if I convert the 10.0.0.0 into a binary language out here, so again, how do I do that? Divide it by 2, or just going to say telling IP to binary converter in, let's say, your Google browsers. If I just take this out and if I just go ahead and hit the address telling this is 10.0.0.0 and say convert IP to binary, this is what I get. So I'll just copy this out and paste it out here. The 10 here in a binary language is represented in the form of 00001010. The 0 here is represented in 00000000, and again 0, and again this one. So these 4, let's say, numbers that you see are represented in a group of 8. Each and everything is a group of 8 here, separated by a full stop. So each and everything is separated by a full stop or a dot here, and each and everything is a group of 8. Each group of 8 is called as an octet. Octa 8, it's telling octet out here. What do I mean by an octet here is that each and every group of this particular address can carry 8 bits of information. It can carry 8 bits of information, and there are 4 such groups. So this is going to become 8 into 4, which is totally 32 bits of information out here. Selling, okay, fine. You have 4 groups separated by, let's say, dot between each and every 8. So each and every, let's say, group can carry 8 bits of information because it's an octet. And there are 4 groups as such. So we get around 32 bits of information in total. And since there are 4 here, right, And since this can carry 32, and sorry, since this can carry, let's say, 32 bits of information, it's called as an IPv4 address, Internet Protocol version 4. You of course have something called IPv6. We'll also look at an IPv6 example. An advanced version has much more capacity to carry more information out here as such. But let's stick to IPv4s and understand what this is, and let's then we can move to something called IPv6s out here as such. But what Microsoft now tells you is that what, yes, or what any cloud provider will tell you is that what, yes, I will give you 32 bits of information. You have a capability to go ahead and, let's say, carry 32 bits of information out here, but as per the norms, you are not allowed to, let's say, use the entire 32 bits. Why? Effective usage, sharing, I mean, for the, let's say for the purpose of sharing, for the effective usage out here, etc., you are not allowed to go ahead and use the entire 32 bits of information. These are a norm which is set by a convention called RFC 1918. There's something called RFC 1918 standards. See, just like we have something like ISO standards that certifies our products, telling that okay, fine, this is the product, and etc. All the private IP address spaces that are available out there come under a norm called RFC 1918. And according to the RFC 1918 standard, it tells you that the maximum amount of, let's say, or it tells you that if you want to go ahead and use this particular address space, you have to give something called as a subnet masking. Nothing but this number, the /16 or the /8 or the /17, so on and so forth. So what I'll do is I'll just again get my 16 here. I'll just put it here in front of it. Now I'm telling /16. Calculating from the left hand side to the right hand side of my screen. This is the direction which I'm calculating. If I am telling /16, I'm telling Microsoft that you know what? I don't want to use the first 8 groups. I don't want to use the first 2 octets. Leave them out. Not a problem. I don't want to use them. So Microsoft says, okay, fine, not a problem. I will give you an address range of 10.0.0.0 /16, which means that the maximum number of addresses that you can have is calculated in something like this. It is 2 to the power, since it's a binary, 2 to the power, the total bits of information, which is 8 into 432, minus the amount of information you reserve. When I say you reserve, the 10 and the 0 here are static. This cannot change. This will not change. So it says 2 to the power of 32 minus 16. It says, okay, fine, this comes down to 2 to the power of 16, which is nothing but 65,536 addresses. Which means out of this range that you have, which is 10.0.0.0 /16, the addresses look something like this. For /16, I'm telling that you know what, this 10.0 is always and always constant. And from this particular address space, the individual IP addresses can look something like 10.0.0.0, sorry, 10.0.0.0, which is the first address that I can go ahead and, let's say, get from this particular space and assign it to one of my resource like a storage account or like a virtual machine and protect the same thing. The second address can be something like this. 10.0 is always constant because this particular 2 zeros, which is 16, this is, let's say, completely static. So I can say it is 10.0. This is always static out here. .0.1. I can change this, and I can also change this. I can also have an address which looks like 10.0.0.2 or 10.0.0.3, so on and so forth. If I write this out, the last address can be 10.0.0.2 255. This is the last number that you can stretch your address spaces to. And if you calculate right from 0 to 255, you get around 256 addresses.
I think it should be 10.0.255.255, right?
Uh, just a second. We are talking about this range, isn't it? We're talking about the series of
Oh, okay,
numbers.
okay. Yeah, got it. Good. Yeah.
Did I change anything? So it is, yes, I mean, I'll come down to your point also. I'll also tell what exactly that is. So it is 0.0 to 0.255. Now you can have one more combination out here, which is 10.0, sorry, 10.0.1.0. Because this can also change. This number can also really change out here. And if I say 10.0.2.0, I can say 10.0.3.0, so on and so forth to 10.0.255.0. Last number, the last digit out here, will again give me 256 addresses out here. I can also have a combination of something like 10.0.1.1 or 10.0.1.2, so on and so forth to 10.0.1.255. This will again give me something like 256. 250 to 55 if I'm not wrong. Yes, 255 because I'm calculating for from 1. Yes, so ideally 255 out here. And if I do this combination, you know what, I can have multiple probability and combination that I can, let's say, work out with this combination. And if I just calculate it, if I just put it into a probability, I can have a combination of 256 into 256, which will again give me 65,536 addresses out here. Whenever someone is asking, okay, fine, what is the range of this one? You can say that the range starts from 10.0.0.0 to 10.0, which is constant, and this 0, the third 0, can go a maximum of 255, and the fourth 0 can go a maximum of 255, which will become something like 10.0.0.0 to 10.0.255.255, which will again give you somewhere around 65,536 addresses out here. Now, this is how it's calculated. But the question is that do I have to calculate this all the time? Do I have to bang my head in calculating? No, not really. There are websites available. For example, there's a very popular website called CIDR.xyz. This is one of the, let's say, website that I use a lot in order to calculate the ranges. So if I go here, say 10.0.0.0 for 16, it's going to give me what is the count out here, telling 65,536 addresses is what you really get out here, and so on and so forth. Again, if you look at this, it's having a color code which tells you that these two are static, and the one that is in gray, it's telling these can change, the number can change. So you ideally get so many addresses, and you ideally can actually secure so many resources out here using this particular address space out here as such. So there are two things that I'm talking about. One being the address space that we are now creating. This can also be called as a CIDR address block. CIDR rotation or CIDR notation out here. Classless interdomain routing. Classless interdomain routing out here. Again, this is the convention that we stick on to, and this is how we really calculate it. But do do we as a DevOps engineer or do we as an administrator go ahead and, let's say, decide how big or how small your network really is? Not really. This is something that we don't do. We as a DevOps engineering team or an administration team is something or is someone who helps in monitoring and also provisioning these resources. But the calculation or, let's say, the number of, let's say, the addresses or the amount of addresses that you need to, let's say, go ahead and go ahead and, let's say, create is given to you by someone called as an Azure architect, or this can come from a client. But in some cases, in a very rare case, the client can ask you that, you know what, if I put a 15, how many, what is the probability that I get? Or if I put a 16, what are the odds? And so on and so forth out here as such. for which we need to understand the basic of what a network really is and how do you really create a network out here, for which either this website or this calculation will kind of help you out here as such. Yes, I'll just take a quick pause here. Any questions that I can address till here?
One
Anyone?
question, Kiran.
Good, please.
So slash slash 16 is the recommended CIDR subnet mask, or can we go with anything?
Good question. Slash 16. Is this a recommended CIDR subnet masking? Not really. Slash 16 is just telling you that what you're getting 65,536. I can increase the amount of addresses or I can decrease the amount of addresses depending upon what my requirement really is. Let's say that I just have in my project, let's say I just have around two or three resources. I'm a very small organization. I just have two or three resources. My requirement is not so many spaces. I don't need so many spaces out here. So what I can do is I can increase the subnet masking, which means I can go for, let's say, something like 18 or something like 24. So if I do that, if I automatically put 24 out here, forward slash 24, sorry, 24, it means it's 8 plus 8 plus 8, or 8 into, let's say, yes, 8 into 3, which is 24 out here, which means these three are static, which means the address that I get here would start from 10.0.0.0 and go all the way to 10.0.0.255. So it's not a recommendation. It's just, let's say, one of the options that is available. But depending upon what is the, or let's say, or what, how big your architecture is, or how many resources that you want to, let's say, fit into your network, we go ahead and decide that out. Now, usually the convention is that if you have about three or four resources, let's say I take an ideal number called four resources that you want to secure within this network, the calculation would always be 4 into 3, meaning 12 addresses minimum. Because four resources, I'm, let's say, going ahead and creating it out, and for future purposes, just in case if I want to add resources, I am just giving, let's say, a calculation. I'm just giving an estimation telling, okay, fine, I need 12 subnets so that in future, if I add something, I'll still have space to go ahead and secure those things out here as such. So it completely depends upon how big or how small the architecture really is out here. Does that answer your question?
No, yeah, it understood. Yeah, I understood it. But
Mm-hmm.
the recommendation, so what I understand from AWS is
Mm-hmm.
it recommends slash 8 as a bigger
Okay.
network
Okay.
with more number of, sorry, not bigger network, more number of hosts, right?
Mm-hmm.
So if I go with the slash odd number, for example, 9 or 10,
Okay.
it doesn't
Okay.
allow you to create a network. So is that
Not
the
really.
case in
If
Azure as
you
well?
No, it's not the case in Azure. So if I go with an odd number, let's say something like 11, I'm still able to go ahead and, let's say, create the space out here. So Azure really doesn't recommend what is the space. All it tells you is that, what, if your architecture is, let's say, wide or big enough and so on and so forth, it will, I mean, it will tell you that, I mean, it will tell you, okay, fine, go ahead and create a bigger network or go ahead and create a smaller space out here. But yes, there isn't any recommendation. You can create any odd number out here like 13 or like something like 14 or 15.
Right. So in
You can
AWS, it
take that.
gives a invalid
Mhm.
CIDR range.
Cider block. Okay.
Yeah.
Okay. But in Azure, no, you can go ahead and create a space even with an odd number in place. That's not a problem. Yes. Any more questions here, guys? But on the other way around, what I can't do is this. See, the biggest network that I can go for here is a forward slash 8. When I do a 10.0.0.0 forward slash 8, I get somewhere around 16,777,216 addresses out here. This is the biggest network range that I can go for, which means that if you observe this, guys, as and when you're decreasing the subnet number, the amount of addresses are increasing, and as and when you increase the subnet number, sorry, increase the subnet masking number, just 24, 25, and so on and so forth, the amount of addresses that you are actually getting are reducing out here. So I'd say Microsoft that, you know what, I want to go for 10.0.0.0/1 or /2. And probably this is the, let's say, error that you might have observed. Telling it is 10.0.0 is not a valid CIDR
Yeah, yeah.
address.
Correct, correct.
Use
Exactly,
something
correct.
like this, right? So if I put a 7, it still says, okay, fine, the enter address space. It's not really recommended to use this out.
Yes, yes.
It's a
This is where
non-routable
my
address and so on
question
and
is.
so forth.
Yeah.
Exactly. So this is because if you look at the RFC 1918 norms, say if I do RFC 1918 standards, and if I just go into the Wikipedia page out here for this, the norms of RFC 1918 tell that for a class A address, which is 10.0.0.0, the largest CIDR that you can actually use is a /8. Any cloud provider or any cloud vendor will stick to this particular norm out here. If you reduce the number to, let's say, something like 6 or something like 7, so it's not about whether the number is odd or even, but it's about what is the recommendation from, let's say, the RFC 1918 standard. And here the largest block of address that you can go for is a /8. Will not throw an error. 7, it gives you a warning telling that, you know what, the address is not, it will not really work correctly because your routing mechanism, your route tables, those won't really work out because you're not really following the RFC norms. If you go for 6, not allowed. No, go for 5, not allowed. 3, 2, not allowed. At the same time, if you go for 32, it says one address, but if you try creating it out, it won't really allow you to go ahead and, let's say, create, let's say, this particular virtual network. I'll talk about why that is and so on and so forth. So the range of addresses that you can really go for a class A address, which is starting with 10.0.0.0, starts from 8, which is the maximum, and you can go to a minimum of 29. I'll talk about why 29, why not 30, why not 31, why not 32. We'll talk about that. But I'll start with something like 16. I'll say 65,536 addresses, and I'll say add. Yes, any questions still here? Anyone, any questions still here? I just want to make sure that everyone is following. If you all have any questions, please let me know. I'll make sure to readdress it. I'll make sure if you're not able to follow it, I'll make sure to address it out here as such. Anyone, any questions before I move forward? Anyone, anything that I can take before we move forward out here? Okay. Now, if I ask any cloud provider, whether it be Microsoft or whether it be, let's say, AWS or GCP, that, you know what, I have an address space. I'm giving an address space here telling it is 10.0.0.0/16. I'm telling them, you know what, this is the address space. Sorry, this is the address space that I'm going for. And Microsoft tells, okay, fine, great. If you're going with this particular address space, you're going to get around 65,536 addresses. You're good. I'll ask Microsoft, can I go ahead and create it right away? Microsoft says, hold on. You cannot directly create an address, or you cannot directly create an empty virtual network. Rather, you now have to tell me how should I divide this space. Just like simple thing, you're going ahead buying a land, you're asking a property dealer that, you know what, I want to build a house on top of it. The first question is going to ask you is that, you know what, how many rooms you want, what is the dimension of each and every room. Is it, let's say, a bedroom? Is it, let's say, a kitchen room? Is it, let's say, a hall? What is the purpose of this particular room out here, and so on and so forth. And you say, you know what, this is the dimension that I need, or this is how big or this how small I need my rooms, and so on and so forth. Same way, the cloud provider is also going to ask you, how do you want to divide your network, how do you want to slice your network out here. And if I divide a network, this division is called as a subnet. A subnetwork, we just call this as a vnet, virtual network. Subnet, subnetwork out here. So it's just going to tell you that, you know what, this is how you divide. Or I just want to tell my cloud provider that, you know what, this is how I want to, let's say, divide my network for effective utilization into multiple amount of subnets. How do I do that? Is just go back into your, let's say, creation page, portal page out here. I'll say add a subnet. And as in when I do add a subnet here, it's telling, okay, fine, you know what? This is your address space that you have given me, which is 10.0.0.0/16. Can you tell me what is the name of the subnet? I'll say subnet. I'll just say subnet 1. I'll just say this is subnet 1 out here, just to give a name out here. Then it's telling me what is the starting address of your subnet. Now, please hear me out. The convention is that when you create a subnet, the subnet should be within the range of the virtual network. Which means if your virtual network is 10.0.0.0/16, you cannot go ahead and add a subnet of 192.168. Something like this. You cannot do this. Your subnet should be within the range of the virtual network, which means that whatever subnet that you add must start with something like 10. And if I say 10.1.0.0, simply telling you know the subnet address range is not contained within the virtual network address space. Why is it so? The virtual network address space, which is 10.0.0.0/16, the 10.0 that you see here is constant. So my subnet cannot have something like 10.1 because subnets should be within the virtual network always. So it cannot have something like 10.1. But can I try something like 10.0? If I just go and say 10.0, it doesn't throw me an error. It's now telling what is the size of the subnet. And I'm telling, okay, fine, the size of the subnet is something like /16. Here it is telling me 65,536 address spaces out here as such. And it is telling me this is what I have. So what I'm doing is that I'm just creating one VNet and I'm telling that, you know what, I just need one subnet out here, which is occupying the entire network space. Not a recommended approach. We'll talk about why is it not a recommended approach. Again, it's just like you have a land, you're buying a house or you're building a house on sorry, you're building a house on top of it with just one room out there. That's it. Not really a recommended approach. It's always better to divide your sub or it's always better to divide your network. And if I go back, right, and this is what the division really looks like, it tells you, okay, fine. After 16, you cannot put a number called 15 here. Not allowed. Reason being, if I put a subnet called 15, I'm just telling that the room size is greater than the house size. It's not possible. So it tells you that, okay, fine, you can start with 16, go to 17, 18, 19, 20, 21, 22, 24, and so on and so forth. What I'll do is I'll put a 24 here. The reason I'm putting a 24 here, I'm just telling that, okay, fine, this is 256. I'm doing a proper division of my network out here, and I'll say add this out. So I put a subnet with, let's say, something like 24. I get 256 addresses. So this is one subnet, which is giving me 256 addresses out here. I can create one more subnet in this space. I can say something like subnet 2. And now I can say it is 10.0.0.0/24 once again. It is telling me, you know what, this address right, that you used cannot be taken because it already is occupied by someone called a subnet 1. So you cannot again, let's say, construct another room there. You cannot do that. Please tell me a different size. Here what I can do is I can put something like 10.0.1.0. My address /24. I can say create this out. Sorry, I can say add this out. Let me go back into my address ranges. And I can again go ahead and say something like subnet 3. And I'm doing something like 10.1.0.2.0 /24 once again. What I'm doing is I'm now having three different subnets inside the same network. And now I can go ahead, I can say review and create a virtual network with three different subnets within the same network, which is giving me around 256 addresses each. It's giving me somewhere around 256 addresses each out here as such. If someone was were to ask me what are the remaining number of addresses, I would say 65,536, which is the maximum, minus 256 into 3, because all these three are occupied. So 256 into, let's say, three addresses are done. And if I subtract that from, let's say, 65,536 65,536, I get the remaining number of the subnets that I can go ahead and create out here as such. But again, with this calculation, if I'm doing, let's say, an equal division of, let's say, the subnets with 256, let's say, addresses inside each and every subnet, I can go for a maximum of 256 subnets, because 256 into 256 will again give you the same number out here as such. So terminologies here: virtual network is going to give you the space. Subnet is a division of the virtual network into multiple small size, let's say multiple, let's say, sizes out here, and you won't be able to create a virtual network without having at least one subnet out here within it. And if you create three subnets, your question can be, can I later add a subnet? Yes, you can later add a subnet. You can go ahead add multiple subnets at a later point in time, and each and every subnet can be used to secure one type of a resource. There can be something called as a front end subnet, something called as a back end subnet, something called as a business tier subnet, and so on and so forth. So we'll be talking about those things when we go into and try to secure our resources and try to, let's say, look at applications and so on and so forth. We'll try to look at those things out here as such. But for now, I'll just take a quick pause, and any questions that I can address till here. Anyone who's not following it, again, I understand people coming from a non-networking background, it might be a little difficult to understand these particular terminologies. So I'm going like super slow. So if someone is not following, please let me know. I'll try to explain that particular area where you are really not following out here as such. Anyone, any questions that I can take till you?
Kiran, here we are using three subnets, right? So totally
Mhm.
256 into 3,
Correct.
so which gives me around 500 plus. So totally we
Correct.
have around 36,000, 35,356, right? So that
Mhm.
total space of 36,356 we have to use. Otherwise, we can use a limited portion of this subnetwork.
So just to correct you there, the total space is 65,536 in this particular
Okay.
address range. So
Okay.
do we have to use the entire space? No, not really. You can, let's say, use a part of it and reserve the rest of them for future purposes out here as such.
What is the cost of this cost for this one? Microsoft is going to charge for total 65,356 spaces, huh?
Uh, Not really. The cost, I'll have to check the calculator once to see how they really charge this out. So I'll have to, let's say, use the Azure pricing calculator to just understand that, because I haven't really looked at the cost of this one. So if I say Azure price calculator, if I go into that subnet, I mean, if I go into that, I can go ahead and give you an estimate, but I need some time in order to understand how the cost is really calculated out here. I can do that. I can tell you how exactly it is charged. As of now, I'm not too sure whether they charge you for the entire space or whether they charge you only for what you use out here as such.
No, the private IP addresses are not chargeable. So as long as you are not associated with a virtual
Hmm.
machine or anything, so just
Hmm.
creation of the subnets, it will not be charged
I just have to check that. I just have to check whether Class
because
A or
you are
Class
not
B is
using that.
charged.
You just create.
That's
Or not
correct.
used.
Yes, that's correct. You're not using that. It shouldn't be ideally charged, but I have to just check what is, let's say, the hidden charges basically that they really cost you out there, because there's something called network voucher RG that gets created and so on and so forth. So I just have to check whether, and because I'm not too sure, again, I'm not too sure about that. I just have to check whether it is chargeable or not out there as such.
Now, if it is a public IP, yes. I mean, private
Mhm.
IPs are not charged.
Yes, true. But I just need to check and I'll just reconfirm on the same thing out here.
Sure.
Please, any more questions here, guys? Anyone? Any questions still here? Anything that I can take?
Hello,
Good, please.
sir. Slash 24. 24 means 8, 8 bits. 8 bit, 1 bit, 2 bit, 3 bit.
Hmm.
8888. 24
Yes.
is constant, sir.
Yes, 24 is constant. So first date, second date, and the third date, which means here, if I say it is
Okay.
24, these three are always constant. So the address that you get
Okay.
will be always like this: 10.0.0. So 1, 2, 3 is constant. Fourth one can change: 10.0.0.1, 10.0.0.2,
Okay.
10.0.0.3. so on and so forth to
Sir, inko one more.
10.0.0.255. Good, please.
Okay, sir. Okay, sir. Subnet also save similarly 1.0.0.1 0.0.2 always not particular గా sir. One ఎక్కువ తీసుకోవచ్చు కదా, increase more subnet space.
Increase more subnet space. When you say increase more subnet space, sorry, when you say increase more subnet space, are you looking to reduce this number, something like 20 or something
No
like
sir,
90?
no sir, particular no sir, particular
Mhm.
space 1 2 3.
When you say particular space,
Particular subnet you are created when
Mhm.
you are created one subnet is 256 address only, one subnet.
Yes, correct. One subnet that
Hello.
I created here is
uh,
256
uh,
address.
I have I have increased more one subnet
Okay, you want to
increases.
increase more on one subnet. So let's say you want to increase the subnet.
Yes.
So what is the space you want to give this? If you say increase, what exactly do you want to do here? Like, do you want to go to 512 or 1024? Let's say I put 1024. Now, if you see, this address overlaps with another subnet already. So when you're increasing or decreasing, you'll have to, let's say, think about how you're dividing it out. Two different subnets cannot have an overlap with each other because the address that you get within this subnet, right, is 10.0.0.0 to 10.0.1.255, which is already an address here. So you're overlapping with the subnet 2. You can increase your addresses provided you can avoid the overlapping of the same. That is the thumb rule of it. Getting it, Trinath? Getting what I'm trying to, let's say, talk about?
Sir, okay.
Yes, any more questions, guys? Anyone? Any more questions here? Okay, so let me delete these subnets. So I'm telling that the largest subnet that you can actually create is at, let's say, something like 10.0.0.0. Sorry, there's the name of the subnet. I'll say subnet 1. So the largest subnet that you can create here is 10.0.0.0/16. Then what is the smallest one? Just scroll down. There's something called 32. I'll say add, and I'll say review and create this out. Let's try to see whether it allows you to create this out. Ideally, it shouldn't, but I'm not too sure why this is allowing you right now. Let
This
me
is
check
an
that out.
IP address, right? I mean, it's not a network.
I'm sorry.
/32 is an IP address. I mean, it's not a network address.
/32 is an IP address, but it shouldn't really allow us to go ahead and create, let's say, a 32/32 out here. But for some reason, it is allowing you to go ahead and do that. But as a general convention, we do a /29 as the smallest address, as the smallest CIDR block for a subnet. Now this portal has changed over the last time that I saw and this time that I see. This portal has, let's say, undergone a change. So I just have to, let's say, look at the documentation on why basically it's allowing us to do that. But it shouldn't allow us to, let's say, go ahead and create something which is greater than 29, because there is something called as an address reservation that comes into picture. What do I mean by this? Is that for sorry, is that for every subnet that you create, Microsoft is by default going to take 5 addresses. Microsoft would tell you that, you know what, if your, let's say, subnet is somewhere around 256, the actual usable IPs that you get would be somewhere around 251. Let me do one thing. Let me go ahead, create a /24 and see whether that's really true out here, because this has undergone a slight change. So I just have to check whether it will allow me to create this same thing out here as such. Now, while creating this out, let me go ahead and allow this to be created in the background, and I'll explain what do I mean by this address reservation. See, you get an address starting from 10.0.0.0 to a maximum of 10.0.0.255, which gives you 256 in total addresses. This is in total, but you cannot use each and every address out here. You can use a maximum of 256 minus 5. So it gives you 251 usable addresses. Why is that 5? What exactly happens to that 5? Is that there is something called communication broadcasting, meaning inside your network, resources should talk via the subnet. For that, Azure reserves one address. The actual IP address itself takes let's say one address out there, and the remaining 3 addresses are for future purposes. Meaning, if Microsoft or any cloud provider wants to roll out an update, they occupy those 5 subnets out here. But I just have to check whether that really changed. So just give me a second. Let's say address spaces. Okay, let's say subnets. And if you see this, in this particular, when I created a virtual network, when I was creating a virtual network, this is allowing me to do that. But after I created a virtual network, the available IPs within a particular subnet range came down to be something called 251 and not 256. The reason being the reservation is coming into picture. So now if I go subnet 1, saying 251 plus 5 Azure reserved IP addresses out here as such. So if I add one more subnet, I try to add one more subnet here, say subnet 2, I cannot do something like 32 here. The prefix must be smaller than or equal to something called as 29. I cannot do a 30 here. If I do a 30, Azure is going to calculate that, you know what, if it's 30, then 2 to the power of 32 minus 30, which is 2 to the power of 2, 4 addresses, minus 5. Minus 1 cannot be possible. That's the reason the smallest can be 29, which is 8 minus 5, which will give you 3 usable IPs and 5 Azure reserved addresses out here as such. So the recommendation here is a range between, for this particular address range, which is starting with 10.0.0.0/16 /16 out here, subnet range can start at 16, can go a maximum of 29 out here as such. If I put a 32, that is not a valid address out here as such out there. Yes, any questions that I can take till you? Anyone, any questions that I can take till you? Anyone, any real-time scenarios, anything I'm going to take right now? Because the last 10 minutes, I want to dedicate the class completely towards questions. So any questions in the current session or any questions that you have in general, I can address those things out here as such.
Just brief
Hello,
of
sir.
Just a second. Okay. One person, please go ahead. I think Lokesh, you had a question. You can go ahead. I'll take your question. Then just give me a second.
If there is no questions, just brief once whatever the class, what you have done entire class. Just brief 2 minutes.
Sure, I can do that. Just before we close it, I can do that. Trinath, go ahead. If you have a question, I can take that.
Hello, sir. In this scenario, I am not. I understand, sir. The
Okay.
sir, little confusion on retention policy. There are
Get it?
two options. Two options: legally policy and time-based policy.
Okay.
I'm not understand. Little confusion. Please
Okay.
explain.
Did you go through the documentation firstly? Firstly, if you kind of go into
Advance.
something called immutable blob storage, did you look at this? Something called
Sure.
time-based retention and something called legal hold.
Sir, ఇది అర్థమైంది సార్ what is this mean? Means you set a particular time.
Okay. Go ahead,
Uh,
please.
you set particular time. The time not changeable or deleted. That blobs
Mm-hmm.
contain data. Legal,
Yes, correct.
legal,
Mhm.
legal hold policy means it not. I am not understand. It is legally produced, sir.
It's not legally produced. Legal hold is very simple. When you go ahead and do a legal hold, let's see what the documentation tells you. It's telling a legal hold stores the immutable until the legal hold explicitly is cleared, meaning you can delete a legal hold policy. You cannot go ahead and delete a time based retention policy. Meaning, for some reason, you don't want to give a particular time. You want to say that, you know what, until the blob or until I am good to delete the data, I want to just lock the data out completely. I don't know what's the time. I don't really know whether it's like 1 year or 2 years or 3 years or 4 years, whatever it is. I just want to hold it until a period that I feel, or I, as let's say a company feel, I want to go ahead and delete this out. That's where legal hold comes into picture. Time based is you set a time. You set a set a time period. Until then, you cannot delete a blob. Legal hold, you don't set a time explicitly. You just put a log there, and when you feel, it can be 1 day or it can be 2 days. You don't really know. In that case, you cannot apply a time based retention policy if you are not really unsure about the date, for which you put a legal hold policy out here as such. That's the only difference between a time based and a legal hold. If you had only an
Sir,
option called time based, good.
okay, sir. That data is locked legal hold policy. How to unlock this, sir?
You have to delete the policy. So firstly, the policy have to be deleted, and then you can go ahead and delete your data out here as such. So when you apply this particular policy, it will also sorry, it will sorry, it will also give you an option to go ahead and delete the same thing. So once you delete the policy, you can go ahead and, let's say, delete your blobs and so on and so forth.
Reading, not access the policy.
Sorry, can you come again,
Not
please?
not you put legal hold policy, not
Hmm.
access the data permanently. You only delete the data.
Not really. You avoid the deletion while putting a legal hold. Legal hold and time-based retentions, time-based retention policies are to make sure that your data are not deleted. Your data is not deleted. You are protecting from accidental deletes. But you can remove your legal hold policy, and then you can delete then you can delete the blob. But with a time-based retention policy, you have to wait for some time to the time that you set to go ahead and, let's say, delete the blob out here as such.
Sir, okay, okay, I understand.
Yes. Any more questions here, guys?
Kiran, instead of in the subnet, and instead of 20, I put wrongly at 16.
Okay.
Can you update that one to the 20?
You can, provided you don't have any resources attached to it.
Okay.
You can, provided you do not have a resource attached to it out there as such. If you have a resource attached to it, firstly you'll have to delink that particular resource and then go ahead and modify the address space out here as such. So I had 24, I changed it to 20. It's possible after you create the it's possible after you create the network, provided there are no resources attached to it at all.
Yeah. Suppose actually we are putting everything network in the virtual network, right? Suppose
Mm-hmm.
I am the end user. Suppose IRCT is the website I am using now. So
Mm-hmm.
it the I mean I am not using virtual network. So because
Okay.
of I am an end user. So
Okay.
in real scenario, without having virtual network, how can I communicate with the um, data? I mean cloud.
How can you communicate with the cloud? See, without the virtual network, you can directly communicate with it. But is your question, how can I communicate with a cloud uh,
Yeah.
within the virtual network? You mean to say in
No,
that way?
no. As a end user, suppose
Mm-hmm.
I have a IRCTC account to book the train
Okay.
tickets. So
Mm-hmm.
how can I communicate with the network cloud? I mean IRCTC cloud.
Mm-hmm.
Without having a virtual network, how can it will be possible? Is it a public network because I am end user?
Mm-hmm. Not really. So that's where your application tier comes into picture. There is something called application tier. There is something called data tier and etc. So I'll put both my data tier, both my application tier into the network, and I'll expose a subnet. That's the reason I have so many subnets out here that I'm creating for something which is a data tier, meaning something which is backend, something which is your data, you don't want to expose it. I will just tell that internet communication is not allowed by putting some policies and so on and so forth. But for something like an application, we'll talk about that. I'm just giving you a very high overview. The reason I'm giving you a high overview is because when we do the actual demo, I'll show you how exactly the application, let's say, really communicates with your data tier in a secured way out here as such. And that will help you, let's say, link things towards each other out here as such.
Okay.
So by default, there is no network, right? When we create a subscription,
Yes.
do we get a
By
network,
default, there is no
public
network.
network?
No, there is no network by default. But when you create a subscription, all you get is a space. So there is no network. All this is hosted on the Azure end. They are controlling the network tier out here, etc. But when you create a resource, you get an IP address for that associated with that particular resource. Public IP address that is associated with the resource. For
Yeah.
example, yes.
No, from where it is coming? It should come from an virtual network only, right?
You mean public IP address?
Public IP address, yeah.
But how will a public IP address come from a virtual network? Because virtual network is a private space.
No, some network. I mean, if it is not a
Some network.
virtual network,
That
yeah.
some network is being controlled by Microsoft. So they
Yeah,
have a
which
host
is
of IPs that they control. Yes, which is good. Please.
yeah. No, go ahead, go ahead.
Yes, they have a host of IPs that they have at their end. So they have a pool of IPs that they have for their resources. And to expose the resource at their end, the entire network layer is controlled at a data center level. So you have a data center, you have servers in the data center. At the data center level, they are going ahead and controlling all the network layer, and they're exposing the service onto the public, let's say onto the public endpoints or onto the public internet using a public IP address, and they are just giving you something called as a fully qualified domain name like HTTPS and so on and so forth out here. So I'm not really controlling when I go and create a storage account. I'm not really controlling the network. I'm just controlling the service, and the network layer is completely controlled by, let's say, my cloud provider out here as such.
One clarification on this.
Got this.
Let's say for the first time when you create a subscription,
Okay.
and you went ahead and create a virtual machine, right?
Okay.
And that got a public IP address and a private IP address,
Mhm.
both
Yes.
together.
Yes. Hmm.
So for that virtual machine to create, it should be part of somewhere, some network, right? So which
Okay.
network is that?
That is your own network. So when you talk about a virtual machine, that's altogether a different, let's say, service that you're talking about. Virtual machine comes under something like an infrastructure as a service.
Right.
So when you're talking about an infrastructure as a service, right? That's when Microsoft expects you to go ahead and create your own network out here as such.
Your own network in the sense one unlike a virtual network, or
Exactly. One like a virtual network.
so that is a private network, right? Again,
It's a private network, correct. So
but
it's a
that
private
private
network.
network, when I install, when I configure a virtual machine, when I deploy a virtual machine with public IP address, but
Okay.
that virtual machine is part of a virtual VNet, which is a private, right? But
Correct.
still
But you still have a
from
public IP address, yes.
public IP, so you can connect.
Correct. You can connect over a public internet using that particular public IP address out here for that particular machine.
So no routing. I mean, all the default routes are allowed in that case.
All the default routes are allowed in that case, yes. If you're coming via public route, yes.
Okay, all right. Slightly different. Okay, okay. Thank you.
Yes. Okay, let's see. What is really okay? What do you really mean by a virtual network? Very simple. A virtual network is a resource that can help you create your own private space on a public cloud. This is your own private space. You're just going ahead and, let's say, slicing a private space and telling that, you know what, this is my own isolation out here as such. That is what a virtual network really means. Network is nothing but a set of cables that you can talk about. But since I'm, let's say, not using any cables out here, I'm just going ahead and, let's say, creating a network on a cloud out here. I'm just doing a virtual space. Virtual is nothing but something which is not physical, which is something that you cannot touch. So that's where I'm going ahead and, let's say, leveraging a concept called a virtual network space on a public cloud like Azure out here as such. So as someone asked, can you just give you a very quick brief? So what we did today is we understood what really a virtual network is, and what do you mean by something called as a CIDR address range. This is a network. This is the range of the addresses that I do have. Then we understood what a subnet really is, and how do you, let's say, go ahead and create a subnet and create a simple virtual network out here as such. This is in brief on what we have done till now. Is any quick questions before I close, guys? Anyone, any quick questions that I can take before I close? Okay, thank you and have a good day ahead, guys. And we'll meet in the next session and we'll discuss more on this one. Thank you and have a great day.